4 equals 0.
Okay, so we are asked to solve this equation?
Using the quadratic formula.
Okay, very good. So then we remember that it's negative b, so a is 1, b is 2, and c is negative 4. Remember, when you use the quadratic formula, you have to have everything in descending order. You have to have the equal symbol, and you have to have 0. If it's not set up like this, you cannot start the procedure. It has to be set up like that. So it is. I don't have to do anything, rearrange, move terms around, nothing. So negative b will be negative 2 plus or minus b squared, which is 4, minus 4 times 1 times negative 4. I already changed this into plus because there is minus from the formula and one of these two is negative. So minus 4ac will be 16. 4 times 4 divided by 2 times a, which is 2. So negative 2 plus or minus, this is the square root of 20, but the square root of 20 has to be written as the square root of 4 times the square root of 5. The square root of 4 will be 2 times the square root of 5. Remember, we do not simplify in a sum. We have two options here. One option is I factor out 2 from the numerator, and I get negative 1 plus or minus the square root of 5, and I simplify, and I get negative 1 plus or minus the square root of 5. The second possibility is I split the fraction into two fractions. Negative 2 over 2 plus or minus 2 the square root of 5 over 2, and now I'm allowed to simplify. I get negative 1. I'm allowed to simplify, and I get plus or minus the square root of 5. Regardless of the procedure you use, the answer has to be the same. But doing something like this is never, never. You have to simplify factors only. So please do not ever do that. Was this the question? Is this clear now, everyone?
What about like square root of like 55?
Okay, very good. So the square root of 55, which is nothing else but the square root of 5 times 11, cannot be further simplified. This has to stay as is.
Nice. Okay. Thank you.
Thank you. Other questions? Anything else from anything else? You choose. Anything else? Okay, in case you remember something else, you can always stop me. I don't mind going back. In the meantime, I would like to start chapter 1. So our test 1 is from R and chapter 1. For now, it's scheduled for the 30th. We're going to try and see if that's possible, okay? I always have a review, a complete review session that it will be on the 28th. So this will be only review, not R from prerequisites, but review of both in preparation for the test. So I have basically 4 sessions to finish, 4 meetings to try to finish chapter 1. We'll see if it's possible. If it's not possible, then we'll move this to the next week. Okay, so chapter 1. Remember to stop me anytime if you have questions, right? It's entitled Differentiation. But we have a long way till we get to that. Okay, so it's good to know the title, but it will take me a while till I get to that concept. Okay. First of all, I would like to go back to the difference quotient. We know what it means is the rate of change of a function between 2 points. Can anyone give it to us?
y2 minus y1 over x2 minus x1.
The difference quotient. Let's go back to our notes.
F of x plus h minus f of x over h.
Thank you very much. Liam?
Yes.
Thank you.
You're
Good.
welcome.
So let me just go back for a second to that graph where this was P with coordinates x, f of x, and this was Q, somewhere here was Q with coordinates, if you remember, of course, x plus h, f of x plus h. And we determined this is nothing else but the rate of change between these 2 points and also the slope. So this is the same with the slope of PQ, normally denoted as MPQ. Now just imagine for me that, or understand the requirement at this point, I want to determine the rate of change here. This is what I want to determine. In other words, I want to determine the slope of the tangent at P. So I can determine the slope of this line. I can tell you what the rate of change of this function is between P and Q. But I want really to determine the slope of this tangent line. That will also be the instantaneous rate of change. Okay, what's the difference between the slope of PQ and the slope of the tangent line at P? And I'm going to switch so you can see me so I can explain for a second. Okay, so I'm driving to New York, and you will ask me when I come back, what was your average speed? You started in Baltimore and you got to New York. What was your average speed? How will I determine that? I will calculate. I will look at my odometer at the beginning of my trip. I will look at my odometer at the end of the trip. I will calculate the difference, and I'll say, okay, let's say I find 200 miles. And in order for me to give you the average rate of change, which is the average velocity on that distance, I will have to divide by the time that I used actively driving, because I may stop for a lunch break or something. So the active driving, the distance divided by the time that I used to drive the distance, not when I was idle. Okay, and I'll give you, this is the average rate of change, the average speed that I had. This is 1, which is the slope of PQ. But now I am actually driving, and you call me and you ask me, look at your odometer and tell me how much is your rate of change now, or rate of change of distance with respect to time. What is your speed at this moment when you have me on the phone? And I say it's 61.5 miles an hour. This is the slope of the tangent at P. The instantaneous, that moment, the instantaneous rate of change. So that's the difference between the average rate of change between 2 points, Baltimore and New York, and the actual rate of change or the speed when you call me instantaneously and say you're passing through, I see you, you're passing through New York, New Jersey, or Wilmington, Delaware. Tell me your speed right this moment. And that is the rate of change, which is the same with the slope of the tangent at P. Okay, back. So here is how we determine this. How I determine this is very easy. It's what you already told me, y2 minus y1 over x2 minus x1. That's very clear. But the question is, how do I determine this? I only have 1 point. How do I determine the slope of a line if I only have 1 point? With 2 points, very easy. But with 1 point, here's what we are going to do. I'm going to move this point. As you already know, h is very small. So I'm zooming in, right? So these two appear very far away. But anyway, let's say I'm zooming out. So then Q moves here. And then I will determine the slope of this line. And then Q will move here. And then I will determine the slope of this line, meaning the rate of change between these 2 points. And then I'm moving Q here, and then I'll have this. And if I move Q very, very close, you see what's happening? The slope of this line will be very, very close to the slope of this line. I just would like you to remember and understand this concept, because that's how I get to that. But we're not ready yet. Okay, so we refreshed our memory on the difference quotient, and we know that our target is really finding the instantaneous rate of change at P, or any point, it doesn't matter. I can do it at Q if I wanted to, which is the same with the slope of the tangent line at P. So keep this in mind. I'll come back. I'll present it several times so you understand what we're trying to do here. Okay, that was one thing that I wanted to clarify. Next in line, let's take a look at these functions. Let's start with this function. Give me a number here.
7.
Perfect. And give me 2 numbers here, anything you want.
7 and 10.
7 and 10 is good. This is a function f of x. How do I know? By the vertical line test. This is a function. Okay, so I would like to ask the following question now. Assuming that I take x to get closer and closer to 7 from either side. Let's start by, I really would like to start with one side. Let's say from this side. What will the function values, which value of y, in other words, or the function, which value will they approach? As x gets closer and closer to 7, where will the function values go? Closer and closer to what?
10.
Exactly. How do we write this concept? LIM limit as x approaches x arrow 7 with numbers larger than 7. We signify that by a plus as a power of f of x. And that is indeed 10. Okay, let's look at the other side. Limit as x approaches 7 from the left. This is how we signify with smaller values than 7. With a power that is a minus of f of x. Let's take a look. As x approaches 7 from this side, what do the function value do?
Get closer to 7.
Closer to 7. This is a concept called right hand limit. This is, of course, a concept called left hand limit. Notice that it doesn't matter whether the function is even defined here. I can change the function. Don't change it. I'll put it back. I'll give another example in a minute. I can change this function and say is not defined at 7 at all. It doesn't have a full point anywhere at 7. The function is not defined at 7. Still, the limits have nothing to do with that. The limits are just the tendency. This is so-called LIM as x approaches a, any number, right? It's called the limit operator. It acts like any operator. What do I mean by operator? This is an operator. It's a square root. It's something that does something to a function. It's a symbol or an operation that does something to a function. Here's another. This is another operator. It takes the function and squares it. And this is another operator. It gives us the tendency. Where is the function going when x approaches a? So two things about this. One more time. X, so this is red, X approaches A, but if I don't have any symbol, it means from either side. It's not specified, which means it can come from either side. By definition, X does not equal A. When we say approaches, we really mean it. So what I'm saying here with this graph from before, I'm saying Q will never be P. Q will never overlap. It will get closer and closer and closer, but it will not be P because H will not be 0. Okay, now I want to come back to our function. It doesn't matter if I fill it in or not. It really is not important. And I'm going to ask this question. The limit Sx approaches A from f of x. This is from either side. It's not the left-hand side limit. It's not the right-hand side limit because it doesn't have any symbol up here. So let's look at our function, the graph that I created here. So as x approaches 7 from either side, I want to know a value, if it exists, that the function values approach. Can you give me a number? As x approaches 7 from either side, can you give me a number in this situation?
No, there's
No.
no values.
Exactly. So the answer here is DNE, which means it does not exist. So one other item here.